System Plan, or ISP. This first workshop is to kick off and introduce the modeling approach. My name is Yesenia, or Yessi for short. I'm on the community engagement team here at OPPD. The OPPD team and I look forward to your engagement and feedback, so thank you very much for taking the time out of your evening to be with us. We are recording this presentation for folks that cannot make it in person, and the video recording will be posted on oppdconnect.com/ISP. Regardless of where or how you're listening today, at OPPD, safety is always our #1 priority. So on the next slide, we have a safety moment. And today I'd like to remind you, when you're pulling out your ladders to do that spring cleaning or that yard work, now that the weather is turning, follow the instructions and the markings on the ladder. Make sure that you're looking up before you lean it against anything. Make sure you're not leaning against any cords or power lines. And always maintain 3 points of contact on the ladder at all times. So 2 hands and a foot, or 2 feet and 1 hand. Now, as we keep safety top of mind, let's move on to our agenda. We'll start by introducing the project team. Then we'll go over what the integrated system plan is and how it's different from the last IRP, or integrated resource plan. Then we'll talk about the process or the framework of this ISP. And at the end of the presentation, we'll do a recap or a quick review of the main ideas from today and what we need from you after today. Now, there's a lot to do, but it's a good thing I have some help. So let's move on to meet the people behind this project and our speakers: Dan Lenahan, Shannon Coleman, Aaron Burdick, and Femi Sawyer. Dan is our Senior Director of Integrated System Planning at OPPD. Shannon is our Director of Energy Portfolio Planning at OPPD. Aaron is our project lead from E3. They're the partner company that we brought on board to help us with this large project. And finally, Femi is our project manager, also from E3. Now, beyond these people, we have a company-wide effort that is here to support this integrated system plan. So I want to give a shout out to our board of directors and our executive leaders for their fearless leadership. Also to the subject matter experts, some of which you will see on the screen, who are working behind the scenes to make sure your questions get answered or addressed. And finally, the rest of the project team and technical support that made this webinar a reality today. We're all here for you today, but you have a job too. So on the next slide, we're going to talk about how you can give feedback. First, live polling. That just means throughout the webinar, we will have little surveys that pop up on your screen. It's a feature here in WebEx in this meeting platform. It's called Slido. So when it's time, I'll give you more instructions on how to use it. The second way to participate is also here during the webinar, and it's the Q&A feature. So at the bottom of your screens within this WebEx screen that you're all looking at right now, there should be a question mark with a Q&A next to it. You might have to click the 3 dots first to have it pop up. But if you have a clarifying question during the presentation, submit it using that Q&A tool. We want to be respectful of everyone's time and want to stay on topic, so please submit clarifying questions only, and our expert panelists and subject matter experts will work behind the scenes to answer your question. If we run out of time or don't answer your question during the webinar, we will get back to you afterwards. Now, if you have other questions or comments outside of today's workshop, we have a place for you to submit those, which brings me to the third way you can provide feedback. I've mentioned the website, oppdcommunityconnect.com/ISP. Well, if you go to that page and you scroll down all the way to the bottom, there are 2 options for your feedback. If you have a thought you want us to consider regarding today's information, or maybe you're watching this recording and want to give your opinion, use that comment feature. Now, if you need us to get back to you, for example, if you have a clarifying question that you thought of after the webinar, or if you're watching this recording and you think of a question, use that Q&A tab, and we will get back to you within 3 business days. As a reminder, the recording will be posted on this same webpage, oppdcommunityconnect.com/ISP. Let's move on to talk about what it is exactly that we need from you. You know how to give your feedback, but what feedback do we want? And we'll share this slide at the end as well, so you are comfortable understanding what we need from you and when. We'll want to get your suggestions on what you think the future will be impacted by. Think about your community or even your household and how they use energy or electricity. What impacts that? For example, do you think there'll be a strong push for climate policy? Do you think certain technology or resources won't be as available, so prices will increase for them? What are the probable and impactful future circumstances that you think could shape energy consumption or generation in the future? Give us your feedback at oppdconnect.com/ISP in that comments section. This feedback is critical because we will use it to set up for the next workshop, which is a good segue into our next slide, which is the timeline. The input you give us from workshop 1 will be used to simulate future scenarios in workshop 2. So there will be a deadline for your feedback, and we'll share that at the end. But your involvement does not stop after the first workshop. OPPD uses the gold standards of public engagement called International Association for Public Participation, or IAP2. In those standards, there are different levels of participation. So we'll need your engagement throughout this entire process, but it might look a little different depending on what stage we're in. So please go to OPPD Community Connect. At the top, there's a About This Site section. There's a link in there that will give you the full spectrum if you want to learn more about IAP2 and our promise to you. This first workshop today, like I mentioned, will focus mostly on introducing this ISP to you and giving you a high-level overview of the study scope. We will be asking for some feedback though, so we're mostly in that inform level, but also a little bit of the consult level as well. Workshop 2 is set for mid-May, and we'll do a deeper dive on the modeling scenarios and data inputs. We will need the most feedback from you after this second workshop. So some inform, but mostly we're involving you in this stage. Workshop 3 in quarter 3 of this year will unpack some initial results. So we'll want your thoughts after this one. We'll do some consulting, but mostly inform. Then in the final workshop, number 4 in Q4 of this year, we will present the final results. So we'll be mostly in that informing stage. Now, before we jump into the material, let's find out who we have here in the virtual room. Which guests do we have today? This is going to be your first chance to provide your feedback in a way, and is an easy practice of that Slido or that poll feature. So before I launch the poll, I'm going to read the question and show you the responses. The question is, which stakeholder group best represents your role in the organization? So we'll want to know which one of these best describes you. And when I launch the Slido, you'll just select one. So pick which one is most relevant to you. And I'm launching the poll in 3, 2, 1, launch. All right, we did get a question in. Are we supposed to be selecting the bullet on the slide? No, I'm supposed to be launching a poll. You're supposed to be seeing it on your screen, but that is okay. We can skip this first one, and I'll try to work on Slido in the background. But until then, I am going to hand it off to our next speaker, Dan. Dan is going to tell us about the ISP and give us more information about that. So we can move on to the next slide, and I'll hand it over to Dan.
All right, thanks, Jesse. So again, thanks for taking time today to engage in our integrated system planning effort. And so again, I'm Dan Lenahan, Senior Director over OPPD's Integrated System Planning Group and project sponsor over this ISP effort. So I'm going to be kicking off today's presentation with an introduction to this integrated system plan, or ISP, including what it entails, its goals, key considerations, along with discussing some major changes that occurred in our industry the past few years and how we are adjusting our planning and modeling approach to the study to address these changes. So if you go to the next slide, I will go ahead and kick this off. So we'll start off by talking about what is this integrated system plan. So it is a long-range system plan that's documented in a report published every 5 years that guides how OPPD will optimize our energy portfolio to provide affordable, reliable, and environmentally sensitive energy services to our customer owners. And so as a recipient of federally generated hydropower, so OPPD is required by the Department of Energy to submit an integrated resource plan to the Western Area Power Administration every 5 years. And we have in the past and will continue in the future to comply with that requirement. But regardless of this requirement, this is something we'll be doing anyway as part of the utility best practices. But as part of this year's planning study, we're going to be adding scope to it to include grid delivery and customer solutions alongside our generation portfolio plans to create a more holistic plan that we're calling the Integrated System Plan, or ISP. So ultimately, this ISP is going to conclude with macro level portfolio recommendations by the end of this year that will likely include ranges of volumes for supply side and demand side technologies, along with general grid expansion areas of interest. So I also just want to take a quick moment to clarify what this ISP is not intended to produce as well, which are those micro level details for things such as prescriptive generation plans with absolute requirements. This is not going to be or tell us future siting for generation or grid facilities, nor is it going to provide prescriptions for demand side management and distributed energy resource programs. Those type of details will come, but they will come after the macro level ISP recommendations are made by the end of this year. However, there's going to be one exception to that. And so as directed by our board of directors last year, this ISP is going to take a detailed look at transitioning our oldest generation plant in our fleet, which is the North Omaha station, from coal to natural gas. And this plan will be more prescriptive for what generation, grid, and or customer solutions that will best support that transition. So we go ahead and move to the next slide. There's some key considerations for this ISP I want to unpack here. So first, the electric industry is heavily regulated, and we have to plan our system to abide by those regulations. Also, the energy landscape continues to be very dynamic. So how do we address increased volatility in this study? Also, the ISP is going to create a long-term roadmap looking out 20 plus years, but our actionable recommendations are going to focus more on the next 10 years. Also, OPPD is going to take a no regrets approach. So what does that mean? Well, what are some decisions we can make today that are beneficial across several possible future scenarios? So we roll to the next slide. Before I jump into describing our ISP study framework, I just wanted to highlight some changes that have transpired in our industry and at OPPD the past 5 years since we did our last integrated resource plan, as it really helps set the stage for how we're approaching this ISP effort. So on this next slide here, over the last 5 years, the electric industry landscape has seen a lot of changes. So we clipped some news headlines and put them on the slide here, as many of these changes have become front and center as far as garnering national attention. One of the biggest changes we've seen is with the electric demand from our customers. We're seeing very high growth rates for all customer classes, but especially in the large industrial customer class, as there's some large industrial customer class prospects that can consume as much power as entire cities, which is just massive and unprecedented. Also, we're seeing increasing intensity and frequency of extreme weather events that has prompted new asset hardening efforts and additional reserve margin requirements to be built into the grid. Along with that, there's been some significant regulatory landscape changes. There was a federal administration changeover during the last election, which has flipped various energy policies in this country. And finally, most are familiar with the supply chain and inflationary cost impacts that in the post-COVID era, but those two things hit the electric industry really hard, where lead times for major power equipment and cost for that equipment both more than doubled over the past 5 years. So what has OPPD been doing in response to these landscape changes? Well, we've been doing a lot, and I want to highlight some of that on the next few slides here. So starting on the next slide. So since our last integrated resource planning effort 5 years ago, we've energized 3 major new large power plants, part of what we called our Power with Purpose effort to support growth and provide local system grid resiliency. So in 2024, we added what is the largest currently operating solar farm in the state, which is our Platteview Solar 81 megawatt facility located in the western part of our service area in Saunders County, which we have a long-term power purchase agreement with that private developer. And just this last year, we energized 600 megawatts of new conventional generation at 2 new power plant sites. Our Turtle Creek station in Sarpy County was energized late last year. This power station consists of 2 large combustion turbines totaling 450 megawatts. Also, Standing Bear Lake Station in Douglas County was energized in the summer of last year. This new power station consists of 150 megawatts of reciprocating internal combustion engines or RICE units. So both of these sites primarily operate on natural gas, but both are dual fuel capable and can operate on fuel oil to support our fuel resiliency efforts, notably during those extreme winter weather events. And on the next slide, so while we were constructing these power with purpose generation facilities, our electric demand growth dramatically increased. And there were some significant regulatory changes which required additional generation reserve margins be put in place regardless of load growth. So we initiated some of the biggest generation expansion plans in our history, which we titled the Near-Term Generation Plan. So this resulted in pursuing over 2,400 megawatts of new generation. That's 4 times the size of the power with purpose effort I just talked about on the previous slide. And about half of this new generation expansion is going to be conventional dual fuel combustion turbines that will be added at our recently built Turtle Creek Station site and our existing Cass County Station site. And the other half of this generation that we're going to build will be wind, solar, and what will be the largest battery storage facility in the state, which we've entered into long-term power purchase agreements with private developers for. So between our power with purpose efforts and near-term generation efforts, when all this is said and done in the next few years, we will have almost doubled our generation capability. And on the next slide, so in order to deliver this bulk power to our customer growth, that requires significant expansion on our transmission and distribution grid as well. So over the next decade, we have plans for potentially up to 400 miles of new transmission line facilities in our service area. That's a 400% increase when you compare to what we built in the last decade, which is just huge. So the picture on the left is a recent example of what some of our large transmission construction looks like. And these large transmission line facilities are the backbone of the interconnected power grid in the US, as they are what are used to interconnect those bulk power plants I talked about in the previous slides, and are what interconnects OPPD to other electric utilities in the region to form that broader interconnected grid. So in addition to grid expansion, we have some large grid modernization plans as well on our distribution system in flight. So we initiated a project to completely replace and modernize all of our 420,000 plus meters with AMI or advanced metering infrastructure. So as part of that AMI effort, we're also replacing and adding multiple new distribution grid and customer software platforms, along with new communication networks. So when this AMI ecosystem of meters, communication systems, and software platforms is complete the next few years, it will result in real-time monitoring and communication capability with all of our customer meters, which we've never had before, which will lead to quicker outage restoration and response times. Additionally, this is also really going to set the stage for us to better prepare our system to integrate a larger adoption of behind-the-meter customer technologies, such as electric vehicles, demand response, distributed energy resources like rooftop solar and battery storage. So currently, only about 1% of our customer base has either an electric vehicle or distributed energy resource on their premise, but we do continue to see a steady rise in adoptions of these technologies and want to better prepare our system to support the likes of these. So if you move on to the next slide, I believe we may have a poll question, and we will see if our polling is working now.
Yes, let us see. And thank you, Dan, for all of that background. There's a lot going on, which means there's a lot to consider for the future. So I want to ask our participants here, what do you think is the most impactful uncertainty OPPD faces when it comes to planning for future energy needs? Let's see what our options are going to be. So we've got quite a few there, but we're going to ask you to pick just one. So I'm going to launch the poll here, and it looks like it went this time. So you should see that pop up on your screen. Go ahead and click what you think is the most impactful uncertainty that OPPD faces. You should start seeing your responses and others coming in. I'll give you a few moments to respond. I am seeing a trend here. All right, looks like got a few more. Right now, our top three are growth and demand for power, followed by federal or state policy direction, and then fuel and commodity prices is after that. All right. Thank you so much, everyone, for your feedback there. If you are on your mobile device right now, the poll should have taken up your entire screen. So to get back to the PowerPoint presentation, just click that back button in the top left, and it should bring you right back. Um, let's move on and keep on learning. Dan, take it back away.
Yeah, I'll just note it's interesting to see the responses there and which ones kind of rose to the top. And I'll just mention this ISP is going to attempt to address all of these uncertainties, but it's good to see kind of where the pulse of the stakeholders are in regards to these uncertainties. Go ahead and can move to the next slide. So now I'm going to get into the framework for how we're setting up this integrated system planning study. And I'm going to start with the regulatory framework on the next slide. So as I mentioned earlier, a key consideration in this ISP framework is going to be to ensure we're compliant with the multiple electric utility regulations. And these regulations are set at the federal, regional, state, and local level. So at the federal level, there's multiple regulatory bodies that regulate bulk power grid reliability, wholesale energy markets, and environmental protections that every electric utility in the country has to follow, including OPPD. At the regional level, OPPD is a member of the Southwest Power Pool region, where they dictate regional resource adequacy and grid reliability requirements, including how demand response can be attributed to supporting those items. They also oversee regional grid interconnection requests and expansion and administer the regional wholesale energy market that OPPD operates in. Now, at the state level, Nebraska is the only 100% public power state in the country. So we have various regulations that dictate retail service area jurisdiction and our obligation to serve customers within those service area boundaries, along with certain approval requirements for new generation and transmission expansion. Now, at the local level, we have an elected board of directors, which governs our rates and sets strategic direction for our utility, which is really important when performing this long-range system planning study. So on the next slide, I'm going to unpack OPPD strategic directives a little more. So at OPPD, our board of directors has created 15 strategic directives, or SDs, that guides how our staff should accomplish our mission. And I plucked out a subset of those and listed those on the slide here, as these ones are having high impact on our integrated system planning framework. Now, I'm not going to read them all, but in essence, these strategic directives provide direction on how we should achieve affordability, reliability, customer satisfaction and growth, and environmental stewardship, which includes our net zero carbon goal by 2050. So we've been given these directives by our board, and so this is where our board's input is strongest and most influential into this integrated system planning study process. So as we work to achieve these strategic directives, our study methodology is going to incorporate these directives into our planning. So we can move to the next slide, which I believe we're going to come back at you with another poll question here.
Yes, we want to hear from our participants one more time. And to reiterate, there are a lot of groups that are helping us to make sure we're staying on course and following those directives, but also helping us to define what the best course should be. I don't know if you caught that 2 slides ago, but you, our customer owners, are one of those local groups we have to consider. So we ask you now, what matters most to you when thinking about OPPD's energy future? And your options are going to be either portable rates, reliable electric service, environmentally sensitive energy, generation, or availability. You will have to pick just one. So I am going to launch this poll now. Give you a few moments to pick what matters most to you when thinking about OPPD's energy future. All right, I'm seeing, let's see, oof, we've got a couple that are racing for the top spot. All right, I'll give you one more second, but it looks like, nope, it's pretty tight. So we've got a couple that are kind of fighting for first place. Dan, you're seeing the results as they're coming in. I'm thinking to myself how I would answer this question. But what else do you have to consider when planning for the future? Please go ahead and take it back over. It looks like we had reliable electric service and environmentally sensitive energy kind of fighting for those two. But again, what else do we have to consider when we're making these decisions for the future?
Yeah, yep, I am seeing the results, and it does look like reliability and environmental sensitivity look to be the top two. So as part of our mission, we're striving to achieve all of these four objectives we kind of gave you for options. And so it may be difficult for some of you to only select one, and that was somewhat by design. But again, we're going to try and achieve all of these objectives. However, we may have to make some trade-off decisions as we're balancing and prioritizing these objectives. So it's always important that we get a good pulse from how our customers and stakeholders would prioritize these. So we appreciate your responses there. So I think we can move ahead to the next slide. So I'm going to now transition from the regulatory framework and strategic directives to begin to get into our study framework. So as I mentioned earlier, we're transitioning from our previous integrated resource planning framework to this new integrated system planning framework. And traditionally, our generation or resource planning focused on ensuring sufficient supply to meet demand. And then separately, our grid planning focused on ensuring sufficient grid capacity and reliability to deliver that supply to the demand. And these different electric system planning areas coordinated with each other using an iterative approach. But now we're taking an integrated approach where we're trying to simultaneously optimize expansion planning for all parts of our system. So there's no commercially available software platform that does this kind of integrated optimization today. But we've developed an approach where different inputs and outputs from both the generation portfolio modeling and the grid modeling will be integrated into our separate standard industry tools to work together to develop a comprehensive macro level plan that's intended to address both generation and grid expansion needs. Now, in the past, an overwhelming majority of our stakeholders have really been interested in the generation portfolio planning framework. So we wanted to unpack that in a little more depth on the remaining slides here we have today. And so with that, I'm going to now transition and turn this over to Shannon Coleman, who is our Director of Energy Portfolio Planning, to talk more about our generation portfolio modeling framework.
Great. Thank you, Dan. You can go on to the next slide. As Dan mentioned, I'll walk through a few slides that describe the modeling that we use in our ISP. But first, what are the objectives that we undertake with system planning? Planning involves layers and layers of forecasting. We're forecasting system demand and energy consumption, future economic development and load requests, availability of new resources and the time to manufacture, design, construct, the cost of purchasing and constructing those new resources, the fuel and operating costs of new and existing resources. We're forecasting what will happen in the rest of the region in terms of load and resource builds and transmission builds, and what the future policy of our region will look like. Knowing that we can't get perfect accuracy on any of these forecasts, and certainly not on the entirety of them, our goal is to plan a future system that can accommodate our lack of perfect visibility into the future with as little negative effect on reliability, economics, and environmental impact as possible. So the planning process tries to achieve the perfect intersection of optimizing the system for the future we expect and minimizing the risk of other possible futures. On the previous slide that Dan showed, you saw an illustration of the number of separate models that will be run for generation, transmission, and distribution, and integrated together to determine the ultimate recommendations for system expansion. Feeding into those models are tens of thousands of inputs and assumptions. In the following slides, we'll focus on just a few categories of those inputs, which you see here on the slide, to introduce them at a high level in preparation for more in-depth discussion of those inputs in later workshops. As Dan described, one of the goals of the ISP is to determine the best way to expand our entire system into the future. But the additions to our generation portfolio are typically a big focus of that effort. The resource modeling, sometimes called capacity expansion modeling, looks at all possible new resource options to determine what types of resources, in what size, and in what year need to be added to our system to serve our expected future load. So we'll review the new resource technologies, both the supply side and demand side options, to be evaluated by the model to support customer needs into the future. We'll also look at the future of our existing generation fleet. We enter each generating unit into the model with its current and expected operating characteristics. We also allow the model to select future modifications to those existing units. The value of the units will change over time as the remainder of the system experiences changes in demand, generation, and build-out of the transmission system. The other side of the equation is the load that we expect on our system and throughout the region, which includes both peak demand and the total real-time energy consumption. The model will consider various forecasted loads representing different levels of future customer growth, economic development, technological advancement, and even adoption of customer solutions. The last major modeling detail that we're going to preview today are scenarios that we plan to construct for the model to simulate. Since the model is attempting to optimize the future portfolio, we need to determine and define future conditions of utility and of the rest of the country as well, conditions in our control and conditions out of our control. But if we model a single future scenario without consideration of other possible conditions, we know that those circumstances will most likely deviate from what we originally projected. So in that case, not only is the portfolio not optimized to actual conditions, but we have no visibility into how the portfolio will perform or the resulting risks or opportunities. So instead, we will model multiple scenarios. The models will ultimately result in a series of what we call candidate portfolios for each of those modeled scenarios. And at that point, we can compare those portfolios and attempt to find commonalities between them and the least risk for system expansion, which will inform our ultimate recommendation. Dan mentioned this earlier, but it's important to note that the recommendations that come out of the ISP will focus on a 10-year action plan. Focusing on a near-term plan allows us to make plans incrementally and allows us to adjust as parameters change into the future. So we'll discuss each of these 4 input categories on the next slides. So next slide. When the model is evaluating new resources, it has the option to select supply side resources, think natural gas plants and wind and solar facilities, and demand side resources, think residential solar and energy efficiency programs. The model will determine each resource's reliability contribution to the system, its total capital cost and operating cost, and its environmental impact. But in addition to the model results that we get for a given resource, OPPD also has to think about the feasibility of each resource in the real world. We have to think about the ability to site the resource in a location that supports the grid and serves load in real time and is in proximity to infrastructure and fuel supply. We have to weigh the maturity of the technology and the ability to bring the resource to market and operate in a reliable manner. We have to acknowledge the risk of a first-of-a-kind technology. We also have to predict how the resource will be able to operate in the market within the confines of today's market conditions, as well as its ability to adapt to potential future market conditions. And another constraint that we have to impose within the model is the maximum build of each given resource type per year, the total availability or constructability of a resource. It's unrealistic to let the model select an unlimited amount of gas, wind, solar, or any type of resource in a given single year. There are a number of factors that limit the technically feasible build on an annual basis. And there has to also be consideration of project timing and deployment over multiple years. So if we move on to the next slide, it's very important to acknowledge and to communicate throughout this process the trade-offs inherent with every resource that will be entered into the model for potential selection. This table is a high-level illustration of the relative value of a long list of resource options according to the various criteria that are listed across the top, and brings to light the realization that not only is there no perfect resource, but there's a very real need to prioritize resource diversity to build a portfolio that ultimately builds together all of the needed components. In the table, green represents a relative benefit, red represents a relative challenge, and yellow means either that the relative value falls in the middle of the range or that the value changes under different conditions. OPPD's generation, transmission, and distribution system aims to balance reliability, affordability, and environmental sensitivity as a complete system. Each type of resource that we can add to the system brings varying levels of capacity and energy, is available very distinctly per season and per hour, has different upfront capital costs and different ongoing operating costs, and has varying abilities to respond to real-time load, real-time transmission availability and congestion, and achieve real-time grid support and long-term emissions targets. The model will look at the future needs of the system and be able to grow the system's capabilities to match these needs using both supply-side options that you see there on the top of the list, anything from coal and gas units to wind, solar, and nuclear resources, as well as the demand-side options that are shown on the bottom of the list, which include energy efficiency, demand response, and distributed solar, storage, and gas. In fact, OPPD has a dedicated team that facilitates our existing demand-side programs and evaluates and designs new programs. And again, the message of this slide is not any one individual characteristic of any one resource, but rather that the model will consider a wide variety of resources that each bring relative challenges and benefits. These will be measured and evaluated, allowing the capacity expansion model to select future resources to optimize the portfolio as a whole. The trade-off between these needed characteristics is why we continue to expand the portfolio in several directions that Dan just showed on previous slides. Thermal baseload, thermal peaking, renewable storage, distributed resources, and demand-side customer solutions. Our goal is to feed the model with the details of each type of resource and allow the needs of the system to determine the resources that are most valuable and build the portfolio in that manner. Next slide. So the model isn't only selecting capacity expansion options in a vacuum, it's selecting new resources to be added to our existing and projected portfolio. Therefore, we have to inform the model on our existing generation fleet and each unit's operating parameters. For modeling purposes, we establish planning horizon assumptions for each unit in our existing fleet. The planning horizons are decision points for future conversion or replacement in planning models, but are not technical end-of-life dates. Planning horizons establish timelines for when decisions about resources need to be made so that we can maintain adequate resource capacity and properly plan the system within the proper timelines. OPPD has commissioned several studies of existing units to calculate the maintenance schedules and the associated costs of continued operation. From that information, empirical evidence of our own units and similar operating units, and knowledge of the common systems and limiting factors at each site, we've established these base case assumptions for planning horizons. These base case model assumptions are not actual plans that we're making for conversion, retirement, or extension. They're just the starting modeling assumptions, but will also allow the model to select alternate options for the existing units. The model will have the option to select replacement, repair to extend operation, retirement, thermal power uprates, or fuel conversions to natural gas or renewable fuels. These options will be available only in the years that align with the planning horizons and the estimated project timelines, and only in the specific scenarios that logically align with these options. As mentioned previously, the action plan that will be recommended as an outcome of the ISP will include only a 10-year period. Within that action plan timeline, the only base case assumption for modification of existing units is the North Omaha retirement and conversion as directed by our board of directors. And I did want to point out also that we will be considering future states not just of our thermal units, but will also allow the model to extend the life of existing renewable facilities as well by selecting a repower option on any facilities where that is allowable under our current contract. OPPD also has several current energy efficiency and demand response programs. Our product development and marketing team administers the smart thermostat, cool smart, and curtailable load programs with and without on-site generation, among several others. Those programs will be entered into the model according to their current size, operating parameters, and customer response patterns The model will be able to select expansion or modification of these existing program parameters as options for system expansion. Next slide. Another one of the primary inputs into the model is the load forecast. This will determine the amount of resource capacity that we need to meet peak demand, as well as energy generation requirements to hedge against market and fuel prices. Dan spoke earlier to the recent increase in large load requests and the continuing challenge in forecasting these types of loads, not just for OPPD, but throughout the country. Therefore, we're planning to model 2 load forecast scenarios that vary the amount of planning load, or the load that's not yet fully contracted for service, knowing that there are several variables that could impact those future load levels. For reference, you can see on this graph that from 2015 to 2025, in terms of peak demand, we experienced an annual growth rate of 2.3%. Now, looking at the future lines, the bottom line in solid gray is the nominal load case. This represents the case where we receive only minimal new load requests and only the current requests with the highest confidence actually move forward to project completion. The nominal growth case grows at a rate of 3% over the next 10 years and 1.7% in the last 15 years of the ISP horizon. The next highest line in solid orange is the moderate growth case. This case includes a lower percentage of current and potential load requests and is intended to represent firm customer commitments plus a moderate projection of requests that we may see come to us in the future. The moderate growth case grows at a rate of 5.4% over the next 10 years and then 3.4% from that point through 2050. And above that, in the dashed orange line, is the high growth case. This case includes a higher percentage of both our current and potential load requests and is intended to represent committed and prospective customer requests, plus a larger quantity of projected unidentified future requests. The high growth case grows at 7.4% over the next 10 years and 5.1% per year over the 15 years following. And in the pie charts on the right, you can see that the composition of our load is expected to change as well, as industrial load becomes a much larger percentage of our total. We receive load requests regularly, some of which is probable and some of which is speculative. The inclusion of a moderate growth forecast and a high growth forecast allows us to encompass the magnitude and the timing of this uncertainty and to explore system expansion plans that serve the two ends of this range. So we're preparing once again to take on a scenario-based approach in terms of load growth as well. If you move on to the next slide, we'll talk about those modeling scenarios. Again, to build the model, there are several assumptions that have to be made, but we know these assumptions reflect only one possible future out of almost infinite possibilities and probabilities. And we want to be able to model a variety of future conditions that we consider to be probable or impactful. The goal is to define these future states as a combination of variables to look at outcomes within a range of possibilities. But knowing that each model run takes considerable preparation and time to run, we have to select a limited number of scenarios that create discrete points within the range of possibilities that we think are valuable to explore. We know there are some variables within our control, strategies that OPPD determines for the future. There's also a layer of variables that are external, possible future conditions of the world around us that we can't control, but we know will impact our system. Each logical combination of these factors will create scenarios that will run through the model to determine system expansion portfolio options. The three main categories of these scenario defining variables or drivers that we want to touch on here are on your screen, and we'll ultimately discuss in more detail in the next workshop. So very quickly through the three. First, scenario drivers can be defined by internal or external strategy. We can foresee OPPD strategies that focus on least cost alone and strategies that maintain various paths to decarbonization. Conducting modeling with both of these strategies will allow us to calculate the relative impact of different decarbonization trajectories. A related external strategy that can act as a scenario driver would be a resurgence of strong national or regional climate policy that could potentially change the operation and cost of our units and other units across SPP. Other scenario drivers could relate to customer demand. As you saw on the last slide, we've suggested a moderate growth case that continues current trends and a high growth case where not only OPPD, but the entire nation undergoes a sustained period of high growth that results in impacts to market prices, equipment prices, commodity costs, resource availability, and unit dispatch. And the last primary driver on the slide is resource technologies. We can consider scenario variables that focus on extending the life of existing assets, scenarios that intentionally invest in nuclear resources, and possibly simulating increased opportunities in cooperation with the Great Plains New Nuclear Consortium. We can also consider a strategy that leans into bringing emerging technologies online within our portfolio versus a risk-averse strategy that continues to focus on mature technologies alone. The drivers listed here are just suggestions, but this is a part of the process where we expect a lot of valuable engagement. Discussion of the variables used to define these modeling scenarios is an area ripe with opportunities for customers to provide us feedback on the variables that should be used and even other ideas to help us create these likely and impactful future states. So now I'll turn it over to Aaron Burdick, Senior Director at E3, to discuss the modeling workflow for the ISP.
Okay, thank you, Shannon. Good evening, everyone. Great to be with you here. My name is Aaron Burdick. I'm a Senior Director in E3's Integrated System Planning Practice. We're very excited to be supporting the OPPD team again in the Omaha community here. We had the fortune of working on the prior Integrated Resource Plan and Pathways to Decarbonization project 5 years ago. So it's great to be with you all again. In this cycle, E3 will be collaboratively working with the OPPD team on the modeling to support the broad range of needs for an integrated system plan. And the core model that's used in a long-term process like this on the generation side is the portfolio optimization tool. So that's shown in the bottom left here. For that, we'll be using the Plexus LT model. This is a model that uses a least cost optimization to build out the portfolio of resources that meet load and resource balance in each hour of the simulation, as well as OPPD's resource adequacy obligations and the clean energy policies in the form of the net zero carbon strategic directive that we'll incorporate. We'll also be performing a reliability analysis using E3's recap model. This will be done at the regional level for the Southwest Power Pool market. This will enable us to determine the accreditation of the resources that we make available to OPPD's own portfolio optimization, as well as to study the reliability of OPPD's on-system loads and resources. The core inputs into these models, Shannon already mentioned some of these. We have the load forecasts, for which we'll consider multiple scenarios. There are existing resources and opportunities for retirement, conversion, or extension. There are new resource options, both on the bulk grid and the demand side. There are transmission inputs and the emissions and policies that we'll model in the form of the decarbonization trajectories. Coming out of the portfolio optimization are a set of portfolios. Those will be further studied in production cost analysis, looking at more detailed grid operations, as well as transmission and distribution studies that look at the grid upgrade requirements on the T&D systems. The core outputs from this process will be the candidate portfolios that were mentioned earlier. So these will include the resource retirements, what resources are added, the costs and emissions of each portfolio, and those can be compared across the candidate portfolios to consider least regrets actions in the near term. So we'll be coming back to you all with a lot more detail on the modeling setup and the proposed sets of inputs and assumptions in workshop 2. And with that, I will hand it back to the OPPD team.
Great, thank you, Aaron. We want to wrap up by summarizing the key takeaways and reminding you of the opportunities you have for providing feedback to be considered in the planning process. So next slide. All right, so revisiting the highlights. As Dan told us, a lot has happened since the 2021 Integrated Resource Plan. We've been working to strengthen and enhance our system in all categories: thermal resources, renewable resources, transmission, distribution, and customer solutions capabilities. These steps were taken to support not only load growth on the system, but to provide needed grid support as well. What we need to know, we need to expand and improve our system. Will continue. And we want to ensure that we're very intentional about the way we study and model the system to determine the right infrastructure and resources to meet customer needs for reliability and growth. This integrated system plan will enable better planning for the system as a whole. We'll be able to more comprehensively integrate generation planning, transmission and distribution grid planning, and customer solution planning. We'll be evaluating supply side and demand side options side by side, and the model will ultimately tell us for each type of resource how much to add and in what year to serve future load and future conditions. That evaluation will center around affordability, reliability, and environmental impact. And because we know future conditions are unpredictable, we'll be defining and modeling multiple future scenarios. The value of each potential portfolio will consider not only its cost, but the risk mitigation it can provide in responding to unknown futures. Like all of our planning processes, the ISP will be conducted within the constraints of external regulatory requirements as well as board strategic directives, and will ensure that we will continue to comply with all applicable regulations. And ultimately, at the conclusion of the ISP, we'll determine a 10-year action plan that will guide our next steps with recommendations for portfolio expansion. Comparing the candidate portfolios that result from the modeling process, we'll look for commonalities that show benefits in multiple futures to mitigate the risk of the unknown, with the goal of recommending a no regrets system expansion plan. The ISP recommendations will also provide guidance on the North Omaha Station transition as directed by our board. The plan will help determine the timing, resource technologies, and grid enhancements that we need to undertake to support the safety and reliability of the system as we move forward with the transition. The ISP will lead to a recommendation based on everything that we learned throughout the process, through multiple models, multiple scenarios, and hopefully with plenty of feedback from the public. So now I'll pass it back. Oh, no, I will not. I have one more slide. As we look forward to the next steps in the ISP, we're going to ask you again to carefully consider the process and look back to these key questions to see what you would like to see reflected in the modeling. And we expect a high degree of engagement, once again, around those modeling scenarios. In this consideration, we pose the following questions again that focus on those main drivers for scenario development. First, in terms of strategy, what are the trade-offs and the impacts of various trajectories of decarbonization and achieving our net zero 2050 goal as directed by our board? And likewise, what are the external policies and strategies that we may see imposed on us as a utility that will impact our planning? And then, faced with unprecedented levels of future demand, how does load growth at different rates impact the magnitude, timing, and technologies of the resources added to our portfolio in the future? What do we expect in terms of load growth? What level of growth do we plan to? And how do we approach the risk of unknown growth? And lastly, in terms of future resources, how does the maturity, availability, and cost of constructing and operating a given technology impact the resulting reliability and affordability of the system as a whole to our customer owners? Where do we want to focus our investments? Mature technologies, emerging technologies, extending the life of existing assets, and how can we best leverage those investments to maximize value and minimize risk? These questions will be the guidelines of how we select and calibrate the variables that we use to define those modeling scenarios. But these should be considered suggestions only, not limitations. We would love to know your thoughts on these drivers, and we would also love to hear your ideas for additional factors that we should consider in addition to these. So now, Yessie will cover all the ways that you can provide your feedback.
Thank you, Shannon. We have a lot to consider for the future, and you, as our owners and members of this public power state, get to bear some of that burden of providing input for the future. So I told you we would revisit this slide again because it explains exactly what we need from you. So by April 23rd, we need you to go to oppdcommunityconnect.com/ISP and tell us what you think the future has in store as far as energy consumption or generation. So in other words, how will people use electricity and how will electricity be created? As a reminder, we'll post this video recording and a PDF executive summary of today's webinar on that webpage. We will also have a link for you to register for the next webinar on that same webpage, oppdconnect.com/ISP. I want to ask our Q&A manager, Angie, do we have any clarifying questions that we need to answer to help our customers do their homework, if you will?
Yes, we've addressed all the questions. Can you hear me?
Yes, I can hear you. All right, that's great to know. In that case, we will move right along. If you do think of any other questions, folks, please go to that webpage and submit them there in the comments or Q&A section. We can move on to our concluding slide. Thank you everyone so much for taking the time out of your evening to be a part of this process and for helping us shape the future. I hope you all have a great night and we'll see you at the next one.